professionals around the globe, the VE leverages our world-leading simulation engine, Apache, to analyze and optimize a building's performance across the entire building lifecycle, from the pre-schematic phase through to post-occupancy. Exchange digital data bidirectionally across different platforms as part of the BIM process. Design decisions for a range of metrics, including prediction of carbon emissions, energy consumption, costs, thermal and visual comfort, and water usage. IESVE software provides users with a fully integrated suite of applications to analyze a range of building performance metrics, with data shared seamlessly across all applications. Assess building form, orientation, and shading options. Optimize for daylight, glare, and evaluate lighting design. Perform accurate heating and cooling loads calculations. Size and compare from a range of HVAC system types and controls. Consider indoor air quality for occupants with natural ventilation and annual simulation. 5D CFD simulation to analyze airflow within space. Decarbonize the built environment by including a range of renewable energy technologies and energy storage systems. The BE includes validated and certified tools for meeting building energy code compliance regulations and various green building rating systems around the world.
All right, good afternoon, good evening, wherever you are logging in from. My name is Liam Buckley, and I will be doing this month's IES Virtual Environment Web Demo. We host these once a month for many of our users in North America. We also host dedicated ones for the US or Canada, and even for individual companies upon request. So if you have a specific need, please let us know. Today's agenda will be a little bit more general about the company and the technology as an overview. So just a quick look at the chat here. Oh, well, glad to have some Chileans on also. Yeah, feel free to add comments or questions as we go along throughout. If you have questions on the topic I'm looking at, happy to spend more time there. I do intend to keep about 10 minutes to the end for Q&A anyway, but I'm happy to roll that 10 minutes into the live portions, especially if something is popular or if it's a hot topic. So IES have been around since 1994. We've got users all over the world. I think they're over 130 countries now. And our core product is the virtual environment software. So we do also provide software training, tech support, and even some sub-consulting. But the primary goal of the business is to develop the virtual environment software platform that is used for the design and compliance of building systems and sites. So here is my agenda, what I plan to run through today. A little bit more of an overview, mostly covered that already, and then go through four main sections. So the main core technology, IESVE software, where and how it's used, and then I'll dive into more specific applications. So how you can do performance modeling and analysis on building envelope, on mechanical systems, look at key metrics like energy and carbon. I'll wrap up by doing some airflow simulation. So you'll capture a few acronyms today. Apologies for that. I'll try and keep that to a minimum, but just so you're aware of what I'm referring to. IES is the name of the company, Integrated Environmental Solutions, and the product is IESVE. So that's the same IES, and then VE is virtual environment. Core to IES is the I in IES. It's an integrated platform of analyses types all rolled into one model. So it saves time and effort by having to support multiple analyses types on multiple platforms. Now you can just roll everything into one platform and have that same model communicate across different analyses types. So if you're familiar with BIM, building information modeling, IES is the BPM of that. So it's building performance modeling, whereby we have a larger umbrella across all performance of building and building systems rolled into one platform. The other major acronym you'll hear me talk about is Apache. That's the main energy simulation engine. Now it does a lot more. It looks at things like cost and carbon and water and comfort, but it also has multiple other purposes. So you'll see that as one of the apps within IESVE software, and that's a really core central application within the tools, and that it's taking a lot of different simulation data in, and it's the real core whole building or buildings systems analysis engine. Okay, so as mentioned, we do also provide training and tech support. There's a portion of the website. I'll actually paste that into the chat now so you don't have to try and track it on my screen. So if you're on the IESVE website, if you go to services, resources, there's a section here called Upskill with IES. And there's an entire library of videos in here that are all free. If you're from, any background, I'd suggest starting off with model geometry. That's why this one is first. If you're a mechanical engineer or energy analyst, I'd suggest you just roll through them. They're pretty well sequenced in order. If you're more architectural leaning, this might be a better first video to start with, in that it talks well about whole building analysis, but dives deeper into more of an envelope specific type of analyses. So let me just paste that link into the chat so that everybody has it. And you're welcome to peruse that at your own leisure. Now, to all of our software users, we also provide technical support. So what that means is maintenance of the online platforms, FAQs, user guides. We also provide email, tech support, and telephone access. On my screen, I'm saying we cover East to West Coast. That's because I'm in North America, but we actually go much broader beyond that. We cover something like 20 or 21 hours of the day, depending on where the user base is working during the workday. If you want to show like a typical training course, we've been doing a lot of these over the last couple of years remotely, is we break training workshops into either 3 or 4 blocks. And that's really if the online video library isn't the preference. This is still really popular that folks want to do live classes. So block number 1, we'll cover geometry and envelope, where we'll do solar simulation, envelope analysis, weather analysis. Block 2, we'll perform heating and cooling load calculations for rooms and thermal zones and generate output reports and spreadsheets for those load calculations. Block number 3 will size mechanical equipment. So that could be airside equipment or waterside equipment. And again, we'll generate output reports showing capacities, airflows, and some checks on the system capacities. And block number 4 is the whole building energy simulation, where we'll generate outputs like energy, site and source energy, energy cost, carbon emissions, water usage, thermal comfort of occupants, and code compliance. So if you're meeting the local codes, whether that be ASHRAE Standard 90.1, Type 24 in California, NECB in Canada, we do energy code compliance all over the world. So it's that last one can be quite regionally specific, I guess is the theme of what that is all about. All right, next into the technology. So as mentioned, the core product is IESVE software, and that is an integrated suite of tools. The URL is up on shown on the page here. So the homepage is iesve.com. Show you that again. We have somewhat of a generic homepage, but if you go to the product section and virtual environment, that is the product that is being used worldwide. So you can get lots more information about the software here. It's really broadly used. Now, this is, I should mention, regionally specific. So if you might want to change your region, you might see different things. In North America, at least, these are the core 6 themes of how IESVE software is being used. So you'll see how like Apache is kind of core and centric to a lot of what we do, but it's not only what we do. You know, we also have lighting and daylighting tools that don't really relate to Apache. Similarly, we'll have CFD airflow simulation tools, not really related to Apache either. I should mention at this point, when I show you the software, you'll see lots of applications. That's not actually how we sell the software. We just sell IESVE software. So you get everything basically rolled into one tool. Okay, so this is probably the most important thing I want you to take away from today's webinar is, you know, answering these 4 questions. So before you use any software tool, if it's to be used for code compliance, you should first ask, is it approved to be used in that jurisdiction? And for the most part, our answer is yes. So we have, for example, within ASHRAE, we do things like ASHRAE Standard 90.1 Performance Rating Method Compliance. And we've been doing that from 2004, 2007, 2010, 2013, 2016, most recently the 2019 code cycles. So I'm showing you the history there, and that's intended to tell you that we'll continue on doing it, and we'll even do 90.1 2022. We're not working on that one right now because we're just wrapping up a California Title 24 compliance option, which is for the 2022 code cycle. That one is in with the California Energy Commission as we speak, and we expect certification on that one next month. In other news, the Florida Building Commission has just certified IESVE 2022. We should have an announcement on that one in the next week or 2. If anyone needs it sooner, we're happy to ship it out to you. It is certified for energy code compliance. So where can IESVE be used? Very broad spectrum here. So if you're doing analysis on what is the appropriate glazing type or the appropriate shading structure or PV array, or what will the surface condensation be on the glazing, or what will the surface temperature be on the glass, they're the sort of really small types of levels of detail where you can use IESVE. It's not always whole building analysis. It can be to solve smaller problems of a surface or of a room, a thermal zone, an individual system. So I'm showing a mechanical system here because in this scenario, you're actually not modeling any building geometry. You're just basically taking a building demand, so that might be a time series demand, and doing analytics on it. So you might be saying, what happens if we have a water-cooled chiller versus an air-cooled chiller? What happens if we have a heat recovery chiller? What happens if we move from a primary secondary loop to a variable speed drive on the primary only? And it helps just answer all those sort of central plant type questions without having to, I dare to say, waste time over deliberations on what the wall insulation is going to be. If that's not the question you need to ask, fine. You know, that's why we have set that model up and whereby it can be like a 15-minute model to do analysis on systems. We also cover buildings, sites, and campuses within the IES virtual environment. So the virtual environment doesn't care how many buildings you're modeling. You can model hundreds or even thousands of buildings in a central model, and that's quite common. Basically, we'll just get a little bit slower the more geometry that you add to the individual model. All right, when to use IESVE? So pretty broad spectrum here also, from schematic, concept, construction documents, design development, post-construction, retrofit. You know, there are common applications across all design phases. The sweet spot, I would suspect, is probably between schematic design and design development. So it can help you to make informed design decisions, and then it can also be used for detailed design. They're the most common. I'm not saying they're the only ones, they're just the most common. And then finally, how to use IESVE. So, you know, the 95% use case is natively, but there are folks who like to do a lot of work in external tools, either import geometry from another source, if it might give you a GBXML file. We most recently announced a connection to Rhino a platform like Revit can give you a GBXML. We even have healing algorithms that can help to fix some of the discrepancies that may come across from a Revit model before it enters IESVE. You also get lots of exports, so you can use Python to automate reports and make them look like whoever you want them to look. So you can actually save time in the future case if you wish to do so. Okay, so I'm going to show you the virtual environment in a few moments. Before I do, I just want to talk about these couple of things in terms of when and how you might use the technology during different design phases. So the core point I want to mention here is if you need to develop schematic geometry, so you're at a schematic design phase and you want to look at different design options, you basically pick a building footprint, select a percentage glazing per orientation, and develop a whole range of building shapes and number of floors. After that, it's up to you what you want to do. Do you want to do energy analysis? Do you want to do daylight modeling? Do you want to do both? Do you want to do energy code compliance? It's up to you what you want to do, but that schematic design geometry tool will help you develop quick geometry schemes without having to spend much detail in developing the geometry itself. Right? These are just guidance tools to help you understand what's better or worse, not necessarily what's the accurate number. Another use case aside from schematic design is shoebox modeling. So in this scenario, you might have a small hospital building here and you want to do analysis on one room highlighted in red. So you can just pull that room out, create a new model and clone it, 32, 64, however many times you want at different orientations, different glazing percentages or window to wall ratio percentages in increments of 5%. Without shading, and that will help you do analysis on, again, what's better, what's worse, what works best on this orientation, what works best in this climate zone. And again, these are like really simple 5-minute box model applications that will show you use cases. So it's not the whole building, it's not the whole city. They're individual scenarios whereby you might use the tools. And then beyond that, if you want to go into a more detailed design, of course, you can detail out and develop those, basically as built three-dimensional models. So the one on the right-hand side, actually, I built that one. This is the ASHRAE headquarters building in Atlanta. So as you can see, the level of detail from accounting for every surface in the building, and that can help to answer a lot of questions. But before we move off that theme of schematic, I also want to show you something whereby you can select a mechanical system in schematic phase. So we call this tool the HVAC System Design Wizard, whereby you might say, I think I want a VAV system and I want it to use hot water and chilled water. And that'll only take 4 clicks. But what that's giving you in the back end is a really detailed component by component based model whereby you can move the same SD model all the way through to construction documents. So the same concept with geometry whereby you might create a model for SD, you might create a model for shoebox modeling, but that model is basically evolving into a detailed model, that's ready for construction documents and can even be used as a calibration model. Same thing is happening in other areas of the software. So for HVAC systems, we set you up with simple and quick ways to do things, but they have a lot of comprehensive details associated to them. Okay, so I want to show a quick demo of the geometry tool before I show the envelope and architecture analysis types. So this is IESVE software. This is what you see when you open it. It's just a little start page. I always recommend taking a couple of seconds to leave this open. This is where we tell you, hey, we've got a new feature out, or new release that has a number of features associated to it. We are likely going to have a software release VE 2023 in April. That's going to include Title 24, 2022. Actually, the headline feature is probably going to be a feature we're calling central plant heat pumps, which we're really proud of and has been over a year in the making. And that will help to address a lot of the electrification needs in the industry that are current, and that will only continue being current. One fun one we worked on over the Christmas period here, a number of our staff developed the version 1 of the Building Performance Modeling Student Handbook. So I've got this open. If you're a student or an educator or even a young professional, I would sincerely recommend you download this. It's free, it's on the website, it won't cost you anything. It's got a lot of core important concepts. So just to show you the table of contents here, it's basic fundamentals of building performance modeling, a lot of important metrics. Then it dives into the envelope analysis, internal analysis, HVAC, energy, fluids, and other. So the core idea with this handbook is you get a new topic on every page. So we've tried to ram as much critical information about fundamentals of heat transfer, important equations that get used, what the different metrics mean, be it site energy, source energy, analysis for climate and weather. A lot of what you'll see here where it's relevant, we'll reference to the associated important standards. Not trying to force you to buy those books developed by ASHRAE, but if you need more information beyond the little snippets we're giving you, we're telling you where to get it. And then similarly, if you want to learn, okay, I can see how you might create a three-dimensional model building. How do I do it? We've also included a lot of free little videos. So the document is short. It's 30 pages or so in length. But where you need more information, we've hyperlinked out to, like this one happens to be, I think it's like a 75-minute video. So obviously we can't put a 75-minute video into a small document. So that's where we reference externally. Opaque assemblies, glazing theory, daylight modeling, electric lighting design. We like to give you useful references and useful sort of outputs of what values might make sense in certain scenarios as well. Same thing for like sky conditions, plug loads, occupancy, process energy, occupant thermal comfort, indoor air quality, heating and cooling load calculations, and again, lots of little webinars here. So these are all redirecting to the website I showed you previously. Again, important equations, HVAC theory, heating, cooling, heat pumps. So when you start using the software, this will help you and guide you and help you understand what it is exactly you're looking at and why it's important. Building energy modeling, electrification, decarbonization, renewable energy and energy storage, energy code compliance, simulation for airflow, and water usage modeling as well. So really useful resource. I recommend you all take a peek. It's on the website. And of course, if you want it, you just click there and it'll take you to it. Similarly, for existing users, we like to continually send out more blogs or Discover IES articles. So I'll actually click on this one. Barajan, who is close to me here in California, he wrote up this little article about VAV system modeling, why it's important, what controls to use, why there might be a fan curve, and he's wrapped it up with three important things here. One, control logic, two, a white paper, and three, a little video. So whichever is your preference of how you like to be educated, these are really useful little blogs we like to send out to our existing users and keep the education going. And then also we like to take in case studies from customers. So if you're an existing customer and you want your case to be posted in the IESVE software, let us know and we'll be happy to get one up on the website and therefore into the software. So to use the technology, you would simply go to new project. You can do things like import from a BIM file. Now that one is going to ask you to browse to an external source. So the only thing you need to be aware of here are the different file types. We can import things like an MIT file, an IFC file, or a GBXML file. This one's probably the most common because you can import from Revit, SketchUp, Rhino, or any other BIM authoring platform that can give you an XML file. Ultimately, we need to search for that. And then the healing algorithm takes over. So this basically parses through data. It can fix data, it can heal data before you import to your project. If that's not your preferred option and you want to just grab an example model, you can do so. You can take what we call starter geometry, These are one of our national labs, 16 prototypes of different building types, plus 4 more California-specific prototypes associated to multifamily buildings, which is a huge building stock, not just in the US or North America, but everywhere. More common than not, though, you might wish to go to the third option, which is your schematic geometry wizard. So this is where you might choose your units, be it metric or USIP, plug in some dimensions, and you'll see the building update its shape accordingly. You can even pick your building footprint shape if you wish. So maybe I'll make this smaller, and you can see the shape update accordingly. And if I move this over a wee bit, you'll see it sort of change like so. This is where you can change your site orientation, or you can simply just plug a number in here if you wish, either or. You may wish to add, let me just scroll back up here. You may wish to add core perimeter zones. So this is really important from a daylighting and mechanical engineering perspective. So you want to add 15-foot perimeter zone. Ultimately, what this will do is add 1 core zone and multiple perimeter zones per orientation. And that will give you load variation across the floor plate. Or in this instance, you might say floors plate, right? So if you want to add 3 stories, you can. Floor planums, ceiling planums, window to wall ratio by orientation, maybe I'll do 80%. And then just basically locate your building. So I'll go, there's thousands of location options here, and you can even customize some of these if you prefer. I'm going to go say somewhere local to myself. So San Francisco, always, you'll have details selected here and then create project. What this will basically do, it will take that geometry that you have developed from your schematic geometry wizard, and it will send that model into the Model It application. So now you're really looking at the useful hands-on version of IESVE software, where you can see all of those applications. Just reduce that down a bit, zoom out. So now you can start doing building performance modeling in a greater detail. So I might even run a little animation here. Right, so now basically what you're looking at is the solar movement throughout the day. And we move inside this building. You should see the solar tracking or the shadows move throughout the building. So there's even some self-shading on this building occurring. That's going to help track solar radiation, therefore solar gains after you know the SHGC in the class, cooling loads, the energy consumption, and so on and so on. Just going to pause that animation now and you get the idea. Hopefully it makes sense. Of course, you can make that image look like anything you wish and move on. So the idea being with the integrated suite here is that you can seamlessly move to any other application. So you can see they're sort of categorized: solar, energy, compliance and ratings, lighting. Some of these are daylighting tools, not just electric lighting. I've got some collapsed here that I don't personally use too frequently. Microflow CFD is a common application too. Now, in addition to the apps-based approach of using the software, there's also navigators. Navigators are basically a workflow. So if you wish to meet the AIA 2030 challenge, you can simply upload your model data to the Design Data Exchange, which is something that AIA has developed to record and report energy model results. This is a really simple workflow. It couldn't be simpler, in fact. This link is basically open up an IES web page where it'll actually give you a little bit more information about what the AIA 2030 commitment is, why it's important for architects, how it helps meet carbon neutrality, and then it'll even show for engineers who might be doing ASHRAE compliance, IECC compliance, and they can upload the AIA model data to that Design Data Exchange. So simple workflow, right? This is one, and this is an action also. Now here's the thing. If you want to do something a bit more detailed, you can hit this little drop-down menu and you'll see a range more application options. I mean, just under the compliance section alone, you'll see tons of options here. So say I was to select ASHRAE 90.1 2019, Appendix G performance rating method. this navigator updates with a ton more actions, and these action items are specific to that compliance type that I've selected. So all of these actions would be click, it'll give you something to do, and once you perform the action, you check off the action item. Click, check off the action, back and forth, all the way until you get some results and some reports. And that's the typical workflow of using IESVE software. Okay, so let me dive back to my slides and help me navigate through some of the topics. So I've already talked a little bit about geometry and solar. There's loads of applications for that type of analyses. In terms of doing envelope analysis, there are a number of options here. Also, this model is going to be moved into the Apache tool. So this is, and you'll see this all over IESVE software. We give you lots of wizards. We give you lots of libraries. We give you lots of templates. So you don't ever feel the need to have to reinvent anything from the ground up. It's much easier to just take something that's templated and make a little modification to it, and to suit your project goals. I think there's now over, I think, 1,500 glazing assemblies within IESVE, and then on top of that, we also connect to the International Glazing Database, so you can actually import stuff from LBNL's window program. Now, in terms of doing envelope analysis, one of the more popular options would be to do daylight modeling. So the metrics available to you there will include spatial daylight autonomy, annual sunlight exposure, and daylight glare probability. So those will meet the needs of IES LM83 as the standard, which is referenced by things like LEED and WELL and others. In terms of electric lighting design, I believe there's, over 700 lighting fixtures available. We actually have a partner for that called Robus, whereby they've got a range of lighting categories where you can basically drag and drop lighting fixtures and perform electric lighting calculations or three-dimensional model visualizations. So you're going to see the range of visualizations on the screen here. Purpose might be a nighttime visualization scenario, a glare analysis that I'm showing here, or a photometric plot across the occupied spaces that will basically tell you the lighting power density on a room-by-room basis. Okay, next is mechanical systems. There's a question here if you can have a copy of this presentation. Yes, if you email me, I'll happily send you out at least a version of this presentation. I'm not showing you anything, though, that isn't already on the website. So, nothing secret here. If anything, all I'm really doing is walking you through where you can find more information on the website. I'll give you more of a detailed demo as we travel through, though. So before I dive into mechanical systems, let me go back to an existing model that I've got again. So I actually changed up my model type here from the one that I created mechanically to a much more detailed one here that I'm showing. So this is a 5-story model. If you want to take it to Apache as an example, or use a very unique specific workflow, you can see how some of these options already have solutions built into them. So let me just firstly show you what the Apache interface looks like. So if you want to, for example, assign, actually I'll select the entire model. Let's just do some review work first. So maybe I want to review the constructions that are assigned, and I'll hit apply. Basically what this will do, it will color code your model based on the construction assemblies that are assigned. So now you get this little legend in the top left-hand corner showing you the construction assemblies. Now you can even look underneath. I can even, if I move that away for a second, make my windows opaque. I'm going to hit apply again. It'll color in my windows. So now you can see the glazing assembly, so associated U value, SHGC, where that's being assigned to your model. Now, to detail those construction assemblies out a little bit more, you would simply go to the Apache Construction Database Manager. And this is kind of a spreadsheet feel to it, in that you're looking at rows and columns. You've got a number of tabs on the bottom here. So you want to detail out an external wall. You'll see loads of options available. Now, I already detailed some of these, or you can import them. But if you want to add additional layers or assembly types, you can. If you want to do something like this quickly, I would recommend using the ASHRAE Construction Wizard. This is simply whereby you say, I don't want to have to reinvent the wheel here. Just give me an R15 continuous installation. I don't know, you might say wood frame wall or steel frame wall or whatever it might be. You can pick it. You can, before you import it to your project, just do a quick review and say, yes, this looks like something I want to import. And then you would import it to your project. So super simple. Only thing to do after that is assign it. Now, Apache, because Apache is like a thermal model calculation, it's used for both load calculation. So let me show you what that looks like at the bottom. Right, this is my next topic anyway. So load calculations. So you're doing heating and cooling loads for rooms and zones between January and December. So it's a design day calculation for each month of the year with an associated HVAC system type. Or you can do energy simulation. That one's much more detailed, same span, but this simulation is happening every minute of every day of the entire year. So that's why the simulation results is a lot larger here. It's almost, it's over 700 megabits. And this is taking in simulation data from the solar simulation tool, the daylight simulation tool, and you can even look at a range of HVAC system options, which is my next topic. Now, before I run any calcs to show you any reports, I just want to show you an example of what's in a typical room. So you'll see some system information. So here you're looking at ventilation data. Now, this is all coming from a template. Building template manager is up here, and this houses all of this data where you might want to say, yeah, I wanted all of the rooms of that type to adhere to ASHRAE standard 62.1. So the good news is, again, we're giving you that data. We've baked that data into the model, so it knows it's going to need 5 CFM per person plus 0.06 CFM per square foot. It's doing a room by room based calculation for you. Similarly, you might want to look at set points. So in this room, you're heating to 69, or that's about 19 or 20 Celsius. You're cooling to 75, which is about 24 degrees Celsius. Internal gains, in this case, I've got some computers, I've got some lighting, I've got some people, and everything is coming from a template. So you don't ever need to reinvent the wheel on that. You also have infiltration options, for example, CFM per square foot of external facade area. And you also have thermal comfort analysis. So if you want to track the comfort of an occupant on a room-by-room basis using different ASHRAE calculation methodologies, you can do so here, be it a PMV, PPD calculation, or an adaptive thermal comfort calculation, or a calculation that reviews the shortwave solar radiation based on the position of the occupant, be they seated or standing. So that's an example of what goes into a thermal model. Next, I want to cover mechanical systems and load calculations. Now, so from that model, I can perform a load calculation. And let me just show you what that gives you. It gives you, I'll do it through the slides first, and I'll show you the outputs. Yes, so the cooling load calculations, it's using the ASHRAE heat balance method. I already talked about templates a little bit, but just to cover again, you're looking at set points, ventilation, domestic water, internal gains, schedules, infiltration. The template looks like this. And I've just shown you what that looks like on a room by room basis. So you create rules with templates, and then you assign them to 100 rooms or 1,000 rooms, and it absorbs all of those rules for the sizing and energy calculations. In terms of HVAC, the next tool I'll show you is the HVAC System Design Wizard. Basically what that one's going to do is generate loads reports. Actually, I'll pause here and show you what it gives you. It will give you loads reports. So these come into, I'll show you the PDF first. So here's an example PDF report that you get on a room by room basis and also a zone by zone basis. So on the left-hand side, you're looking at the cooling loads for each room and each zone. This is where you'll see sensible cooling load, latent cooling load. Center block is the heating loads associated to the rooms, and the right-hand side column, you'll get some summary information about the individual rooms. So, you know, basically the geometry, supply air conditions, ventilation requirements, and some checks in the lower right-hand corner. And you can see where all of the loads are coming from. Now, it's a lot to review. You know, in this case, we've got a model here with 260 rooms in it, so it's a lot to review on a page-by-page basis. That's why we also give you a singular spreadsheet output that has summarized all of the zones and all of the rooms in a simple table. Okay, so everything in blue are associated to your cooling loads, everything in red associated to your heating loads, and green associated to ventilation. Now, the nice thing about this load output report from IESVE software is that we are maintaining all of the formulae. Okay? So if you want to tinker with something, you can, right? We also acknowledge that you might want to add an oversizing safety factor. So if yours needs to be 15% instead of 10%, you can just update that and all your loads update accordingly. So I can see some of my rules of thumb calculation got flagged as, you know, something it's a spreadsheet, right? So you can go and do whatever you want to it afterwards. As we move from rooms and zones into systems, so after we've done our load calculations, we might need to size some systems. The next goal of a report is going to look like this one. So this one looks very similar to the room and zone, but this time we're including mechanical gains and losses. So that now you're getting into cooling coil sizes, airflow requirements on the AHU, heating coil sizes, entering air conditions, leaving air conditions, and much more detail on non-coincident design engineering checks and coincident. This makes sense because it's a VAV system. Okay, so let me talk a little bit more then about the HVAC system types. Quick view here. Yeah, good question from Max. Can you change ASHRAE 90.1 years in the navigator within the same project? i.e. code requires ASHRAE 2019, but lead requires 2016. Will this require two models? That's a really good question. You know, since it's a really good question because of the versions of ASHRAE that you used. So ASHRAE 9.1 2016 is, at least it's been sold as this stable baseline model, if of course you're using the performance rating method. So the only thing that's supposed to change is the building performance factors, you know, because it's supposed to be having a stable baseline, which really only means you're making edit superpose model. So in theory, you could have the same model and just edit the building performance factors. In practice, though, you more than likely have mandatory prescriptive requirements on the envelope. Like you say, one is for code and the other is for lead. I would probably apologize to you and say it's probably going to be faster to have two models. Now, on that point, there's loads of ways of moving data between model A and model B. For example, you can export out your geometry. You have to do that in Model It. That's why it's ghosted out here. In terms of thermal data, you can use a tool called Master Templates, and you can use the template wizard export. You don't have to do that because natively in the model, if you want to select data, you can go to tabular space data, just copy all of this. We even give you options to either export the entire thing or export stuff from a certain tab, and then paste it into Model B, or you can use the Master Template Wizard. And then finally for HVAC systems, that's just a file. So you can move that file, you know, in Windows Explorer. You don't even have to do that natively in IESVE. The only thing you need to do potentially is reassign your zones. But yeah, the workflow navigators, that action there factory proposed data set. Once that import happens, the rest of the workflow becomes locked to the rules associated to that version. So it's going to get confused, and sorry, that's a tricky one. Good question though. Okay, I was about to show you the HVAC system design wizard, which is a tool here, and which basically launches you into Apache HVAC. Let me just do it real quick. I'll use an existing system, and that'll help me move through a little faster. All right, so I'll just pick an existing system that I've already got set up. Page 1 of this HVAC system design setup is really about zoning. All right, so you can already see I've got zone groups, then zones, then rooms. So you can see this sort of tiered level of hierarchy. Next, going into page 2 is an airside system selection. There's, actually I haven't counted them, 60-ish HVAC system types available here. As you click into each system option type, you will see the visualization update. And then if you need more information about what's going on in that system, you can click on the image and it'll tell you, oh, this is a dedicated outdoor air system with chilled beams. Image will probably schematically try and lay that out for you. Default configuration will explain to you exactly what you're getting. And then it's basically assigning those systems to your model. So I can already see I've got one in here for air source VRF. That's why there's a little one in there. Page number 3 is all about the water side. So in this case, it looks like I've got some air source VRF. And it looks like I've also got some DX cooling. And it looks like I've got some heat pump systems on this one. So next, into the final page, page 4, this is where you can perform heating and cooling loads. I've showed you the outputs for that already. You can perform system sizing. I've shown you the outputs for that already. And you can perform energy simulation. I'm about to show you that. Now, I'm not going to run all these calculations right now because I've already done it for this model. So I'm just going to say, okay, I'll show you what else you get. You get this detailed component by component based HVAC system setup. So we use the wizard to set the model up, but what we get is much more detailed. What we get is component by component based modeling. In this case, I'm looking at a supplier fan with what looks like to be a variable speed drive fan curve. If I was to perform energy, actually, let me go back to my slides. Yeah, so huge range of systems available. I don't really think there's anything we're missing that's common in the industry. We're very aware of the continual pivot towards all electric designs, and we have a new central plant heat pump model coming out that will help to address those configurations. But yeah, we've got dedicated people that work on our HVAC system maintenance. In terms of what's available, airside I showed you previously, but you know, on the heating side, it can be hydronic heating, it can be you know, heating for AHU coils, radiators, radiant panels, domestic hot water. The cooling side, it's chillers, DX, heat pumps, cooling towers, water side economizer, heating / cooling or a hybrid approach. We've got both air source and water source VRF options or heat pumps. They can either be, you know, air cooled or water cooled, heating mode only, cooling mode only. We've even got some manufacturer performance data sets built into IESVE software. Earlier last year, we added a heat recovery chiller. And that plant-only analysis, as mentioned previously, you don't need any model geometry to do that. If you want to do that type of analysis on a 50-building campus, all you actually need to do that plant-side analysis, you know, ultimately you're basically modeling like a virtual network of plant. You would use our functionality I'm showing you here on the screen, where you basically import 8760 heat demand, be it on the heating side or on the cooling side. Now, I've used 8760 because that's the number of hours in the year. In other words, that's the number of rows you need on a spreadsheet from that import option. So in terms of the outputs, we've already discussed some of these spreadsheets, PDF reports. You also get visualizations in the Vista Pro application. For any individual component, you can track how it performed. So let me show you that really quickly as well in the Vista Pro application. And tracking that can be really important from both the load calculation perspective and the energy simulation perspective. So just to speak to that one really quickly, this little green chart here, or this chart with the green line on it, that is a design day load calculation. I know that because I can see it's 12 design day calculations. So in other words, January doesn't like line up with February. Well, of course it doesn't, because they're different calculations, just have to be shown on the same chart. And that's what we use for design day calculations. Whereas the graph on the bottom, that's for energy simulation or energy modeling. And that's where you will see every day of the month, sequenced and you're capturing whole building energy analysis. So when we talk about energy, we typically talk about energy throughout the entire year. So the energy output report is here on the right-hand side, and that's basically showing you site energy, source energy, and CO2 emissions for every energy end use in your model. So you can see here I've got an EUI of 24. However, over here I've got an EUI showing to be 17. That's because this EUI graph is including the effects of renewable energy sources. So that's why there's a thick inner ring inside of the thick outer ring. So the thick outer ring here is basically the pie chart of energy uses, and the inner ring is energy contributors. So usage was an EUI of 24, but with renewables it drops down to 17. Now that's how to look at energy holistically, or carbon holistically. If you want to look at it on a month-by-month breakdown, you can get this stacked bar chart. You want to look at how the fuels are contributing to those energy end uses. You can see this little Sankey diagram. So this is electricity, this is gas, and this is your renewable energy contribution. Those are the energy costs, and then peak demands. This all comes in a single one-page report, native from the Vista Pro application. So just to show you that one live. Once you perform calculations and simulations, you'll be automatically taken to the Vista Pro application. This is where we can do, as an example, so once I click on a simulation scenario called VE2022, this is just something I had named previously, you can go and generate energy report. So that energy report is this one, the energy model output report, simple one-page report that will tell you everything about your model in terms of how it's performing. There's loads of other options in here. So if you wish to do some custom analysis and you want to see, I'll do like an energy breakdown where I'll stack my lighting on an annual basis with maybe receptacle equipment, refrigeration, space heating, DHW, cooling, and so on and so on. So you get the idea, right? It's almost a troubleshooting tool whereby you can customize any of these energy outputs to look like however you want them to look. Donut chart, if you want to dig more into just one energy end use, like lighting, for example, you can look at that on an 8760 basis. So now you're looking at an XY plot. If you're confused about what's happening in some week in February, then cool, let's look at February only, and we'll track its performance over a daily basis. So we can see when it's dipping off and when the lights are turning back on again. So this tool will also help you understand that's an energy analysis, but you can also get that same level of detail on an individual room by room. So in this case, I've selected a room, and similarly, if you wanted to concern yourself with the lighting for that just one room, again, you can track it on a room by room basis throughout the entire year. And I can see it's sort of like stepping. It's not necessarily dynamically dimming. This one looks like it might be dimming a little bit more dynamically in the evening time. Why is it dimming more dynamically in the evening time? Well, if you continue on through looking at some of these outputs, you might be able to track things like daylight illuminance. So it's as illuminance naturally is coming into that space, electric lighting might be dimming accordingly. So that's the idea with whole building energy simulation. Similarly, there might be water consumption from this building. I can't actually recall what I've included in this model. Let's see if this gives me any data. I don't. Oh, okay. So I've actually got some cooling coil condensate. So in other words, because there's a cooling coil in this project, what I'm actually doing here is I'm collecting water that potentially could be reused elsewhere. That's why the number is negative. Everything else in here is a consumer of water. So if I have any evaporative cooling, and I do, this is the water consumption that's being used throughout the year. So it's energy, it's carbon, it's water, it's cost, and so on and so on. So let me run through some of these slides. So from water, energy, code compliance. Yeah, so we do code compliance all over the world. Oh yeah, one of the other output reports, actually I'll just show you two output reports. I've already shown you the navigators, right? So this is where you will streamline workflow. The real magic is in this button here. So it takes your proposed design and it will automatically create the baseline model. And then just to save you more time, it will automatically generate your output reports because it's doing a comparison of proposed versus baseline. So what that looks like is a simple PDF report like this. There are those building performance factors I was referencing previously. All right, so there we go. Energy and cost summary by fuel. So it's basically doing this proposed versus baseline energy comparison. Okay, so then it'll do this PCI calculation. Now that's what you get in terms of a PDF report. We also give you that same information in the spreadsheet. Obviously, the bonus with a spreadsheet, as mentioned previously, you're maintaining the formula. You want to tinker with something, you can. You want to get like costs per square foot on the energy, you can. And again, if you want to tinker with some of those building performance factors, all of these are open and editable in terms of what you might be using. And then this little graphic will update accordingly. Okay. So we're doing good on questions so far. Feel free to type in any questions if you've got them. Okay, so I've mentioned Title 24 already. That's a new. IES has been certified in California for the 2013, 16, and 19 code cycles, so we're expecting news on that imminently for the 2022 code. Mentioned floor already. We're including actually 60.1 and 170 in the ventilation calculations. Report export to AA 2030. And then just to wrap up really quickly, rather than show you some of the airflow by way of slides, I might actually just show you the web page on it because it was updated last week. So, if you're looking to do airflow simulation, we've added a number of use cases here. So it can be passive natural ventilation design where we've got an operable window with cross-flow ventilation to also an operable window on the far side. It might be an atrium design whereby we might have an operable skylight at the top of the atrium, thus inducing air into that atrium. In terms of active CFD simulation, it might be for a data center. So in this case, we've got hot aisle containment. That's why you're seeing these burning hot aisles in the center of these data centers. Those areas are being contained by sending cooler airflow to the server racks, airflow traveling through the rack into that contained area and then exhausted at high level. We're tracking things like air temperature, age of air, air velocity. That type of CFD simulation can be used for ASHRAE standard 170 for a typical operating theater. There's actually a lunch and learn video on that. I did that one. Thermal comfort analysis. So if you're comparing, say, a chill beam versus underfloor air distribution, external wind studies, car park, carbon monoxide modeling, and so on. So let me paste that link into the chat as well. Question here, can you demonstrate importing a Revit model and what room data is carried over? I am not a Revit user. I can show you how to import a Revit exported file. Yes. So we do a new project. And I'm going to get rid of this here. So I'm going to create from BIM file. I'll browse for one. Sketch models. Which one of these might be? Gosh, I can't remember now. Let me just grab one. And so these are Revit export files. So before I do that, I just want to show you this options button. So this is the healing algorithm rules. So just to talk through that, for example, it knows not to include structural columns. That's going to put a room inside a room, and then your performance model is going to be garbage. So it needs to look for areas in your model less than what you input. So I've given this quite a low value, and if it sees any, it will ignore it. It's taking this ABC approach. So it's going to do A, that doesn't work. Do B, that doesn't work, do C, or you can check all the boxes and do them all if you wish. Then finally, it's going to ask you, do you want to perform all those healing calculations upon the import? So you'll see it cycle through a couple times to do that healing process. I'm going to leave that alone. It looks to be fairly intelligent. So I'll just try open. Gives you a few options of what you want to import. So I think part of your question was what data does it give you? You choose, right? So if you only want geometry, this is the most common option I should mention to you of the import option for folks who do the BIM to BPM import there can be a lot of garbage in the BIM model that's not necessarily thermally useful. But just to show you, I'll do the geometry plus assigned data create project. As it's copying over, I'll just tell you what it's going to bring. It's going to bring all of your geometry. By geometry, I mean, oh, down. Yeah, okay. Crashed on me. So that was an old Revit model. That's not normal, by the way. Typical of a demo. Yeah, so it brings all of your geometry. That doesn't just mean your occupied rooms. It also means shades, adjacent buildings. It also brings your site data. So that might be latitude, longitude, weather file. If not, it'll find a weather file for you. Thermodynamically, it will bring materials, all your opaque and glazed construction materials for your model. Try a different one here. It will also bring all of your internal gains, so lights, people, equipment, plug loads, associated profiles too. It will bring heating and cooling set points. You get this little report, by the way. You just click on the report. I'll come back to it in a second. Best analysis you can do is a visual analysis. So what I mean by that is if the geometry was bad, what you would see is a missing wall. Like you would be able to see into that room. The important little trick here is what you're looking for is a list of rooms here. If they weren't picked up as rooms, they would be shades. In other words, just a wall patch almost touching another wall patch, but that's not a room. A room needs to be sealed or watertight, and that's what's going to give you good results. It doesn't give you any mechanical systems because that's not what's in the GBXML file. You do get this little report. It's kind of like a dynamic report to say if it's missing any areas of greater or less than, this number, apply and show me what that looks like. So I can see something was open. So cells in yellow is not wrong. It's just saying, hey, take a look at this. In this case, sensible gain exceeds this value, which I can see by just eyeballing it. That is a really, really high value. That's telling you there might be something off with the floor area that was imported. Might also mean there was a typo on the heat gain that was imported. It just means take a look at it. It doesn't necessarily mean it's wrong. Where do I recommend downloading more weather data? Great question. So from, oh, you know what? We actually put a button in the website for that, or on the B for that. So this is the tool called AP Locate, which is where you import all of your weather data. As you move through that wizard, it will ultimately take you to this third tab called Simulation Weather Data. There's a button here called Get More Weather Files. Click on that button, it'll take you to the place that answers your question. Where should you get more, or could you get more weather files? Let me just talk you through some of these. So, right, this one's really popular in that it can get any data in a 30 kilometer by 30 kilometer grid worldwide. We can get you actual meteorological data, which is what you might use if you're doing model calibration, or you can get typical meteorological data. For example, if I want typical weather for the last 10 years, then that's what you would need to ask for. Those weather files, I think, are maybe like $70 a pop or something like that. Let's see what this looks like. Okay, $80. So you need to find a location, latitude, longitude. You tell it if you want a TMY. Then you need to tell it over how many years. I don't recommend going lower than 10 years, to capture the typical trends. Otherwise, the data might become a little bit too old. Weather shift is something that you might take one of those Athenian locations and morph weather for like a 2030, 2050, 2080 scenario. Those scenarios are based on, sort of guesstimated performance criteria where you might say, show me the hellish type landscape that I'm going to be in 50 years time. But those RCP scenarios, they'll be detailed. Click into the order now. And the last location worth mentioning is probably this one. This one is free. The other two are at a price point. These are old though. So yeah, you'll get good locations here, but the data won't be current. So this data, I think, gets you up to, I want to say, 2004 or 5. And obviously that's old, right? And I'm sure wherever you are in the world, you've experienced stuff in the last 5 or 10 years that is not typical. So, possibly somewhat ambiguous with the term, what does typical weather mean? But yeah, they would be the 3 locations. And I'll actually just paste this link into the chat for everyone so they have it too. Good question though. Thanks, Lucas. Okay. I think I've gone through a lot of the CFD stuff. 9 minutes over, but those were good questions. Yeah, just to wrap up then, integrated technology, happy to be a partner with either like a equipment manufacturer incorporating their equipment into our software, or doing project-based training with our users, or posting their case studies on our website. We're more than just a technology provider. Maintenance on all of our codes and standards, and indeed we have a dedicated web page for that, which I think is probably worth actually pasting that into. Actually, I'll show you where it is. So on the IES website, under resources, there's a section called software validation, and IES internally come here more often than I suspect than our users, just to say, where are we on ASHRAE 140? Where are we on ASHRAE 183? Where are we on 195.2000? So we're trying to maintain these all the time. And resubmit our software versions for various states, codes, jurisdictions, so that we're constantly staying on top of it. And then solutions. The solutions I've showed you previously, they range from looking at a surface to a room to a zone to a system to a building to a site and to a campus. All available within IESVE software, and the range of metrics: site energy, source energy, carbon cost, water, comfort, lighting, loads, equipment capacity, renewable contribution, you name it. So that's everything I wanted to cover. So my details are up on the screen. Feel free to email me if you've got any other questions, or if you wanted a copy of the presentation, or wanted to have a quick chat to go through your own Q&A. I'm part of a much bigger team also, so happy to share your details with one of our team members that might be local to you, or managing the region that you might be in. What is the plan for 2022 T24 approval? So it's in. It went in like 2 months ago to the Energy Commission. So it's in review at the moment. It's not unusual, by the way, for them to take that long to certify the software, because it's over 200 models, which is ridiculous, but that's a different conversation. So they have been reviewing it, and we can see that they're actively reviewing it for the last number of weeks. We hope to be told by them within the next few days whether or not it will be certified in the April business meeting, because they need to post that docket 3 to 4 weeks in advance. So we should know very soon whether it's certified. I will say also, we've done this certification for the 2013, 16, and 19 code cycles. We're kind of used to it now. We're kind of used to the Energy Commission now, so we don't expect any issues. Plus, we can see the results of the 200 plus models, and we know they're all good. So likelihood, mid-April for that commercial software release for the 2022 code. That's going to be for new construction, commercial. We don't do single-family residential Title 24 compliance. And there will be additions to that software tool throughout the year, specifically in the area of existing and alteration. This one is for new construction approval. Just means we can get them in faster. Oh, good question. Are there Spanish versions available? Not in the software. There might be in some of the output reports and in some of the navigators. Good question. I might need to ping a colleague to answer that question. So let me just show you real quick. I do know. I do know it's relatively easy. This might be one. Yeah, it's relatively easy for us to update a workflow navigator to a specific language. I do also know it's relatively easy for us to generate output reports in a specific language. What I don't know is how amenable some of that stuff might be to the user interface. I know there's no Spanish version of that. So apologies for that. But let me have a coworker follow up with you on that one specifically. Question here: is the license based on a per code cycle or per year format? All of our licenses are annual. So what that actually might mean, it might bridge a code cycle. So for example, if somebody has an active license today and we release a Title 24 compliance software tool next month, you just get it. You get it for free because it's something that we've released within your code cycle. And that's going to happen every year. We have about 3 software releases per year, major ones, and we've got some smaller bug fixy ones too. We're always updating ASHRAE codes. We're always updating Title 24 codes. We're always updating NECB codes. We're always updating UK Part L codes, Irish Part L codes, always. So it just sort of depends which code cycle is turning, typically in a 3 to 5 year cycle, depends on the region. But yeah, in the meantime, all of our licenses are annual. Does the software use a key or a login? One person may want to use 2 different computers. It does not use a login. That is something that we had got planned for, possibly next year. I'm not too sure. But as of right now, no, you just open the software and it's good to go, which means it's tied to your computer. It is also tied to your email address. So the license structure is basically a single user standalone license, which is what I have on my machine. You can also have a network license, which basically means you can have 100 people with the software installed, but they're all pointing towards the same license file, which can be located on a network. Okay, so that's like a sharing process. And we've only 2 options there. You either have one network license shared, or you have an unlimited network licenses shared. And the unlimited network license shared is specifically twice the price of the single license that's shared. That's why we don't have a price point for 2 licenses or 3 licenses or 4 licenses. You go from 1 to unlimited. So we only have 3 products to simplify. Good questions. Follow-up question. So 2 employees could use the program, but not at the same time under 1 license. That is correct. Yeah, it's like a floating license, in other words. So what happens, by the way, is if employee A goes to open the software and it's being used by employee B, it'll tell them on their screen, hey, employee B is using the software, so you don't have a license. That's actually what happened at my old company where I used to work. Before I joined IES, you would have to pick up the phone and say, hey, when are you going to be done? Otherwise, add more licenses, which, as you can probably imagine, IES prefer. Oh, by the way, if that ever does become a strain, you're also welcome to upgrade mid-term. So you can always just start off with 1 network license and then upgrade to the unlimited one, 4 months in or 6 months in or whatever it might be. And like those associated costs are prorated to the term. So you'd only be paying for the remaining 6 months or the remaining 8 months or whatever it might be. Can you pick or choose the plugins or products? I only showed you 1 product. This is the virtual environment product. Plugins. Oh, can you pick and choose the applications? No, you can't. That is a model we had over 10 years ago. We don't do that anymore. It's actually a lot more expensive to do it that way. So we just bundled everything up and called it IESVE. Here you go. Good side is if you're not interested in the CFD tool, but you might want to try and sell that service to a client one day, you have one. You have one right at your fingertips. Yeah, sorry, that's just the business model. It's simple though, so here's IESVE. Here you go. We do have some other plugins from other products that we use, but I haven't shown those today. They're available on our website. I know there's 1 plugin in SketchUp, but I don't believe it does anything unique that I haven't shown you today in the virtual environment. In fact, it's like almost a watered down version of what I've shown you today. Okay, you can see the thank you notes here. You're welcome. Okay, great. Okay, yeah, email me. Let me show that one screen again. If you've got And I can see a couple of names here I might already have an ongoing conversation with. I see you. I've seen it. I'll reply to it. I promise. I just haven't got to it yet. All right. Great. So, you know, we do a free 30-day trial. You have access to our business development team during that period. If you've got questions, feel free to go to the website, download, and play away. Thank you all so much for your time today, everybody.